Now, in the previous section, section 3, we had some general things about probability, and we're going to dig into it now a little bit more. And in fact, if you remember from section 8.2, we went over this. If we have union between sets E and F, we have to subtract those that intersected so that the numbers wouldn't be counted twice. So in a sense, we've had this rule already that is called the addition rule of probability, which should be an old friend maybe, or at least hopefully an acquaintance. Let's go on and see an example. In example 1 here, they're going to introduce us to what is called a roulette wheel, and the person that drops the marble in, the wheel goes one way and he throws the marble the opposite direction, then the wheel will stop and we'll get into one of these slots over here. And what's coming up? Well, there are 38 slots in the roulette wheel. There are numbers 1 through 36 somewhere, and these are arranged randomly here. I see the 1, okay, there's the 36 there. And so that will give you 18 that are red, and then there are 18 that are black, and they add 2 other slots, a 00 and a 0. So on the roulette wheel, there are 38 slots, 36 are numbered, and then there are 2 that have no numbers assigned. There is 0 and a 00. And these are not called odds or evens, but the numbers, of course, there are 18 odds, as we said, and there are 18 even. See, and I have an idea of what the wheel is like, and you have this picture too. So you can use your booklet as a reference to the roulette wheel. We want to find the probability that the marble will land on a red or an even number. Well, based on that, we said there are 18 that are red out of 38, and of the 36 numbers, there are 18 that are even, but we now have to subtract those that are already included. We have to subtract the red that are already included here. So in a sense, and again, it's out of 38. I had inadvertently wrote a 36 there. So 18 are red, 18 are even, but 8 of the reds over here are also even, so we had to take those out. So that's what we have here. So we end up then with 28 out of 38, which are 14 out of 19. You always want to simplify. In example 2 now, we're going to roll some dice. And dice, of course, is the plural of die. And find each of the possibilities. So on the next page of our text, and in your booklet actually, you have the outcome of this. So we'll do letter A first. The first die shows a 2, or, so this will be union, the sum of the results is either 6 or 7. So to see this, I'm going to move to the next page, and you can just look at your booklet. Now this little chart is one that works out very nicely. They have what one die will be, a 1, 1, 1, 1, 1, and then the other being a 1, a 2, a 3, a 4, a 5, a 6, and they lay it all out. So we have 1, 6 this way and 6 this way. So the possibilities when you roll the die to get any one of these is going to be 1 out of 36. And if you get all of them, that would be this 36 times, which will be all the others, 35 out of 36, which would equal 36 out of 6, or the whole, the 1. Now, how many, when you roll, will have at least a 2? Well, there's 1, 2, 3, 4, 5, 6. So that would be 6 out of 36. Now, how many will have a sum of 7? I'm sorry, I guess it was a sum of 6 and 7. Yes, both of these. So we can count them. This is a 6, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 11 possibilities out of 36 that it's going to be a sum of 6 or 7. But notice, and I like the way they laid this out, that you're going to have 2 that are repeated. So we have to subtract these 2 here, and we end up with then 15 out of 36, and we can take a 3 out of each one, so that would be a 5 out of 12. And again, the use of this chart is going to be, I think, very useful. We're going to use it for a couple of examples. Now, for letter B, the sum is 11, or, again, this is union. The second die shows a 5. Well, we can just make a new little chart using the same one. So there's a 5. And then the sum is 11. Well, to get an 11, we have this right there. And there are 2 ways to make an 11. And there are 6 ways to make a 5. But notice one of them is repeated, the 5 and the 6. So when we set this up, it will be the 11 this way is 2 out of 36. That will contain a 5 this way is 6 out of 36. And that 1 is repeated. We have to subtract that out. So this gives us then a 7 out of 36. And that works out very nicely. Now as we continue, we see we have if events F and E are a disjoint. Of course, by definition, it's an empty set. So hence, the probability when they are a disjoint of those events occurring together is 0. And they're showing that as a rule down below. Now, for example 3, assume that the probability of a couple having a baby boy is the same as the probability of a couple having a baby girl. It's not quite that, but we're assuming it's going to be 50-50. And if the couple has 3 children, and we did one like this in an earlier lesson, find now the probability that at least 2 of them are girls. Well, here's the listing we had from that tree table that we developed. Now that you're going to have at least 2 girls, there's 1, 2, 3, 2 girls, and at least 2 girls also appears in having 3 girls. So they're showing that down here as having the 3 girls first is 3 out of 8. Having the 3 girls, 1 out of 8. When we add this together, we get 1 out of 2. So 50-50. Remember, there are 8 possibilities, and then that you will have 2 girls at least is 50%. Now notice, this is also then reflecting that you will have a possibility of 2 or greater number of boys. So something to think about, and our answer, of course, here is 1/2. Now, having a little review is never a bad thing, so here's our Venn diagram. There's our set E. There's our sample space, the universe. So what is outside set E? Well, we had said a number of times E complement. So if we have the whole, which is 1, and we subtract from it E, we're going to end up with E complement. And they're giving us the official rule here. Or if we have the whole and we subtract E complement, we're going to have E. This is what they're discussing here. And hopefully you're taking notes on this. So, if a fair die is rolled, what is the probability that any number but 5 will come up? So here we're going to say 5 is 1 out of 6. The universe is 6 out of 6. And if we subtract not 5, which is 1 out of 6, well, not 5 is 6 out of 6 of the whole, that it's not a 5 now. That would be 1 out of 6 would be the 5. We're left with 5 out of 6. Didn't explain that too well, but hopefully you're catching on, and we see it here. So this is that we would roll a 5. That is our event, and we're subtracting it from the whole, which is in a sense 6 out of 6 minus 1 out of 6 gives us 5 out of 6. I've mentioned this before. I don't like the way they put that slash there, but that's okay. Alright, now in example 5, if 2 fair dice are rolled, find the probability that the sum of the numbers showing is greater than 3. Well, if you look at that chart we had of the various outcomes, we can have a 1 and a 1, a 1 and a 2, a 1 and a 2 this way. So there are only 3 possibilities when you roll a set of dice that there's going to be numbers that are less than 3, as we see here. And we did say earlier that the universe of rolling dice is 36 out of 36. And if we just subtract the 3 that we are not looking for, then we end up with 33 out of 36. And if we factor out a 3, we get an 11 out of 12. And that's what they're showing us here. So in this sense, we're using 1 minus our event that we're looking for, and that will equal the complement of E, which is all of the others. That's what they're showing here. Now, in our next part of this, we're going to take a look at something else, which is referred to as odds. Now, you may have heard of this. What are the odds of something? And how does that compare to probability? So far, we've done probability. Now, you recall the rule for probability was the probability of an event was a ratio of the items that you are looking for out of the total items in the sample space. So I don't know if that's the super correct way to show it, but that's it in words and a little bit in symbols. Now, how do odds differ? Well, that's what they're going to show. For instance, if they say that the probability of something is 4 out of 5, and you want to change that to odds, well, we do so by saying the event you're looking for is going to be 4 out of, well, not out of, 2. What is the other event that's not going to happen? There's just 1 left down here. So we say that the difference between probability, 4 out of 5 possibilities, when we shift it to odds, the formula would be 4 out of, we have to subtract now the event we are looking for from the total events, and there's where we get our ratio of 4 to 1, and that would be odds, and this would be probability. But let's look at some, and weather forecasting is probably a good one to work on. Suppose the weather forecaster says the probability now of rain of tomorrow is 1 out of 3. Find the odds in favor of rain tomorrow. Well, keeping in mind what we've just said, we're going to have rain out of rain plus no rain So as we look at that, it's 1 out of 3, and that's going to be 1 for rain out of 1 rain plus 2 no rain. So the odds then, once you set it up like so, will be 1 to 2, or 1 in a ratio to 2. 1 to 2. 1 to 2. Now, if you want to say, what are the odds of having no rain? Well, if it's 1 out of 3 for rain, then it's going to be 2 out of 3 for no rain. That's the probability. But then the ratio of odds would be 2 to 1, 2 to 1. This is no rain to rain. So, again, they're similar, but you'll be challenged on knowing the difference. So, here's the summary. I like the way they set this up. So, this is rain out of rain plus no rain. That would be probability. And then when you want probability of no rain, there's your no rain out of the sum again of rain plus no rain. Now in example 7, they're suggesting that weather forecasters often give probability in terms of percentage. They'll say there is a 40% chance of snow tomorrow. So find the odds of snow. Well, it would be 40 out of 100. So snow is 40, and if you take away 40 from 100, you get 60. So snow to no snow, or 40 to 60. And if you simplified that as they are doing here, this will be, cross these out here, and you can take a 2 out of each one of these, so this would be 2, 2, 3. And then of having no snow, which is the 3, to 2, you just reverse them. But again, going from percentage now, you see it's an easy conversion. And be sure you're asking questions if you're not sure of something. Now in example 8, the odds that a particular bid will be low bid are 4 to 5. Now they want you to change odds to probability. So how many bids are there? If you have 4 and 5, well, you have 9 bids. So that's your sum. And then 4 of them would be the low bid. So there's where they're getting the answer, 4 out of 9. That's probability. 4 to 5 is odds. All right, in example B, find the odds now that the bid will be the low bid. Well, that ratio is 5 out of 9. So the chance the bids will be low bid So the odds against now low bid are 5 out of 4. They're putting it in a combined fraction form, but these 9s actually just cancel out there, and you get 5/4. And I may have missed the not the low bid. So 5 is not the low bid. And again, there were 9, so it's just 5 out of 9. All right, as we look at example 9 here, I had to make it a little smaller so it would fit on the page. We're going to say, let's set A represent the driver in a fatal crash that was 24 or younger, and B will represent the driver that had a blood alcohol content, a BAC. This is the legal limit, 0.08 of 1% or higher. From the data on fatal crashes in the year of 2010, from the U.S. National Highway Traffic Safety Administration, we have the following probabilities. That A is this, and this is what I'm putting there. There's a point, this. B is this, and I'm putting a point that there for B, and they're showing us the intersection. So what we need to put in now is that intersection reading, which will be 0.0536. Has to fit in there. Now, from a previous lesson, we know how to take this and then find out which are just the A part and not intersecting with the B part. So we're going to subtract this from that, and that's going to give us this figure right here, 0.1541. And then we're going to subtract this intersection again from this, and we're going to get 0.1644. And they have this down here. So we now want to find our complement then of A and B. Well, we have to find what is the total of A and B by adding these three together and then subtracting it from 1. And when we do that, when we add these up together, which is going to be 3721, so you can see the mechanics of it, this will equal 0.6279. Okay, so this is the information that we've put on a Venn diagram to figure out our intersection. And from the data that we have, what would be A would be this, what would be B, we had to subtract that from the 2, or do it this way. So the actual answer then to our question, find the probability that a driver was 25 or older. Remember, 25 or older is out in the complement area of our Venn diagram and had a BAC level below 8%. That would be this value right there. And that's what they're showing. And that's how we got to it. Now, part B of this is rather interesting. Find the probability that the driver in a fatal crash is 25% or older, or has a blood BAC below 0.85. or 0.08%. And they're stating it corresponds to A complement in union with B complement, and we actually did that in an earlier lesson. When we shaded this step by step, it looked like, I could have used my other pen here for that the only thing left here was the intersection. So if we want to find what is our complement of this that is shaded, we would add up this, this, and this, which is what they're showing right here, and it adds up to this. Or another way of doing it, we could have gone 1 minus our intersection, and it comes out to the same answer. Ooh. Again, you have a lot on your plate and you're wondering what method to use. I happen to remember this. Example 10 gets a little challenging. We have data from the 2012 Forbes magazine survey of 100 highest paid, I have a little tongue-tied here, executive officers, CEOs. And they're classifying them by age, in years, of course. And let E be the CEOs that earn less than 25 million, wow. And F be the events of CEOs age in the 60s. So we have a couple of things here. And I've listed all of these charts in your booklet. So we have here that earn less than 25 million are going to be these. So we have the grand total of 60. And I have these charts in your booklet, so we'll go on to our next. All right, so for example A of this, we want to define our sample field. So we had that already highlighted. It's going to be 60 out of a total of 100. So our probability of earning less than 25 million, wow, is going to be 60%. Now we want to define what our F value is. Those who are 60 or older, and our total here is 45. So in B, we are looking for the intersection here of this with this. So the intersection is 31 out of 100, which is 31%. And in letter C, we're looking for the union of set E with set F. Well, set E was 60. Set F is 45. But notice we do have intersection, so we have to subtract the 31, and when we do so, we end up with a total probability now of 0.74. Now, you'll have your exercises to do, and if we have time, we might do some in class. Here are a few we can play around with. We can pause.